Well, folks, this is the lecture one of week 10 of the computer engineering course. And what I have on the agenda today is discuss the situation where the physics that we have to put in a problem is more complicated than being able to describe the information in a single line as a formula. So what you want to do is perhaps include in that physics statements such as if time is less than 5, then this is what's going to happen, else this is what's going to happen. In other words, we want to include the if, else, then statements in our problem. So in doing so, I will go ahead and talk about rules instead of formulas. And we do two problems first. One is the block traveling down a track that we have done several times, but we said, for example, the velocity was constant or the acceleration was given as a constant, velocity was linear, the particular problem that we did. Or, for example, an arm turning around a base, where we assume that there's a constant angular velocity. And then once I do that, then I come back and do a bit more complicated problems. Okay. So here's a situation that we want to consider. We have a block that is traveling along a track that we have already done, except that the velocity of this or the position of this block is no longer quadratic. Remember, the very first problem that I did for you, I assumed that the acceleration of the block was given to us, it was a constant, and by integrating backwards twice, we get the position of the block as a function of time being a quadratic function. Stuff from elementary physics, okay? But here, what you want to do is, for example, say if the time is less than 3 seconds, the block should stay stationary. But then between 3 and 7 seconds, the position of the block should be linear like that. That means velocity is constant. And then after 7 seconds, the velocity reverse, or the position actually goes back to where it was. In other words, zero position. That means that the velocity is linear, but in the other direction. Basically, this is the statement that you want to put in our formula. Not formula. We can't do it with a formula because formula is a single line. We have to do it in something called a rule. So in order to do that, once you create your model, and you're already very good at doing that, once you create this mechanism, then you go to the knowledgeware, okay, and knowledge advisor, and there you're going to get statements that you can actually write rules for it, okay, such as this. Notice that this says if the time is less than 3 seconds, the position is 0. In other words, distance is 0. If the time is less than 7, obviously bigger than 3, then the position, you can see that it varies, the position varies linearly, you can see that. So it's going to be time minus, you have to include that 3-second shift in it, because otherwise it just doesn't make sense. And then times the speed of 5 inches, this is 5 inches over 4 seconds, there we are, etc. And then I will make some comments that you have to be careful. For example, you can't leave this S out. You can't say if the time is less than 3, 3 does not have unit. Or when it comes to writing the expression for the velocity, you can either say, for example, 4 inch per second, 4 inch divided by 4 seconds, or you can say 1.25 inch underscore right here, 1.25 inch underscore S. You cannot say, you cannot say 4 inches underscore, for example, 4 seconds. It is fussy. Okay, so we're going to do this problem. Okay, so let's go ahead here and insert my first part, and I'm going to call this thing track. Right click properties, I'll call it track, and that's the thing that's going to be stationary, track, and track. All right, let's move on. Let's make it. double click on it to go into part design. All right. On that vertical plane, I will sketch. The dimensions don't matter here, but what I'm going to do is I'm going to make this thing, for example, yeah, let's make this thing half an inch, 0.5, 0.5, and this thing maybe 1 inch. Actually, let me make it let me make it 2 inches. Okay, exit. And then I'm going to pad it by 10 inches. So that's going to make my track. Good. Now we go all the way to the top. Insert the block. So insert, new part in there. Say no. Right click properties. And I'm going to call it block. And block. Okay. And we're going to make double click on the block. So you're in part design. On that same vertical plane, I will sketch. Where is that? I will sketch a little box. Maybe 0.5 by 0.5, just to make it look good. Actually, I'll make this thing 1. And I'll make this thing 1 also. Okay. And then I'm going to bring this thing and put it on that. So this line, control that line. You're going to make it coincident. Very good. Exit. Okay. And let me pad this thing by 1 inch. Make it 1 inch. Okay, so that's going to be my block all the way to the top. And I will let me save everything. File, save management, save as. All right. And that's pretty much it. So now we're going to go to, why don't we create our constraints here. So let me anchor the base, all right? And then coincidence between this edge and that edge, and coincidence between this plane and that plane. And that's going to turn into a prismatic joint later on. Okay? So we're done here. We're going to switch to digital markup, DMU kinematics. We're going to get the magic wand out right there. There's the magic wand. New mechanism. Auto create. And needless to say, this is going to be a prismatic joint with 1 degree of freedom. Right there. We're going to make this thing angle, length driven. Double click on it. Length driven. And notice that right now, the joint limits are minus 100 inch to 100 inch. Now, it is okay. It's just that, it's unnecessary. I can go from 0 to 100, but then I'm going to flip this direction so that it moves in the other. See the arrows? See? I want it to go in that direction. Really, that doesn't matter. I'll leave it the way it is. No problem. Mechanism can be simulated. You know how it works. You click on that. Now, notice that there we are. So it is working. Reset. So put it back really quick. Now we want to put the physics into this thing. Remember what we did before we went into formula. We're not going to do that, but I want to remind you what happened. F of x. We click on the mechanism, and I made this thing equal to, this is the position along that track, equal to whatever formula I want, which happened to be a quadratic. But I don't want to do that because I need more than just a single line to express that. So how do we do this? Remember, I told you that you need to go to Knowledge Advisor, Knowledge Advisor. So I go here. By the way, there are other ways of doing this thing. And if there is time, I will show you that, but not right now. So start. There is your knowledgeware, and there is Knowledge Advisor. Okay. Notice that here we have a toolbar. This is easy to spot because, first of all, for some reason they call it the reactive feature. I'm not sure why, but you can see that there is an icon here which says if X, Y. That means you're writing a program basically. Now you click on this, you click on that. It says you're trying to make a rule. You can have as many rules as you want, but this is the first one, rule. It's made by me on the 21st of June. And we say, okay, this opens up. So what you get is a window like that you can write actually your program in it. Okay, so let's go ahead and do this. All right. Now, notice, by the way, I'm not interested in everything. So this is everything in the model. Down here is everything in the model. If you click on mechanism, it only goes and concentrate on the stuff that's related to the mechanism. Okay, you click on the mechanism. You see that? Only the time and the length pops up. So what I want to say is if time, remember what the definition of time is? In other words, the symbol for time, mechanism 1/kin time, double click on it, it puts it there. If kin time is less than 4 seconds, see my rule? 3 second actually, not 4, is less than 3 seconds. 3 second, 3s. Okay. Then what we say is that the position is 0. So right here, this is the position, length. Put it there, equal to 0. Don't forget the inch, 0 inch. Else if time, once again, less than 7 seconds, see this? Less than 7 seconds, mechanism equal to, starts at the position 0 because it's sitting there. You go to the next line. The length equal to 0 inches plus, it's unnecessary to write that, but I would like to add it. Parentheses, your velocity came out to be, you can either type, what is that, 4 inch divided by 4 seconds, or you can say 1.25 1.25 inch underscore second. So 1.25 inch underscore s. This means 1.25 inch per second. Close the parentheses. If there are any syntax error, we're going to find out. We click on this, we're going to get the error message, okay? All right. As a matter of fact, let me show you. Well, let's move on right now. Yeah, times, parentheses, kin time minus that shift that I said, 3s. See that? 3 seconds. Right there. Times mechanism time minus 3 seconds. Okay. And finally, else. That means the last condition. Else distance equal to. Now notice that if you look at this drawing, it is sitting at 5 inches. So 5 inches, and then it's going to go that way. So velocity is going to be, velocity is going to be, let's see now, velocity is going to be 5 inches over 3 seconds. Okay. All right. So we're going to say equal to 5 inches. That's where it's sitting. Plus. Now, the question is, how do you want to write this thing? So, for example, if you say 5 inches over 3 seconds, there are different ways of doing it. You have to do it in a way that it won't cause a syntax error. For example, I can say 5 over 3 is 1.6 6, stuff like that. Or if it's too much of a hassle, what you can do is you can say 5 divided by 3 parentheses close. It's not as this is a number now, times parentheses 1 inch underscore s. Now I don't need that parentheses probably. Okay, you can try. Now you might have said, can I write it as parentheses 5/3 inch underscore 7? Well, I'll let you try it. So try it, because this is very fussy. So anyway, this is equal to your time minus, don't forget the shift, minus 4s. And if there are any syntax, we're going to get it. And that's pretty much it. Now, first of all, let's check for the syntax error. If I say click on this, okay, no syntax error. Now, what I'm going to do is do the following. So I'm going to take this thing away, for example. I'm going to try to see if I can write it like that. Let's see. Okay. Syntax error. You've got to be very careful in how you write this thing. Now, if I say multiply, probably they'll take care of it. There's a parenthesis here. I can take that parenthesis away. Let's check it out. That's okay. So listen, you've got to be careful on how you write these things. So it's up to you how you want to do it. But I just showed you, the way I would do that. As a matter of fact, I don't even like this. I rather write it as parentheses to avoid making mistakes when it comes to reading and things like that. If you, for example, forget the minus s here, or s here, look at what happened. No syntax, but this is not going to work, because when you try, it says units are not consistent. That's not the syntax error, but the problem is that you're mixing two things together. Okay, so you definitely need to put s there. Yeah. All right. And that's fine. You say okay. If there are no syntax error, this is going to close, and double click on this. If you want, you can get it back. By the way, if you want to copy and paste these things, for example, let me do that for you. Let me try highlight this. See, there is no copy and paste, but the Windows shortcuts work. For example, you can say Control C, Control C, and you go to the next line. I'm going to delete it in a minute, but next line you say Control V. Look, it puts it there instead of you typing that whole thing, but I don't want it. Okay. Hopefully I didn't make a mistake here. That's okay. And that's pretty much it. So we have a law, and now we're going to do simulation with laws. Let's see now, where is the simulation with laws? Right here, simulation with laws. Yeah. Over a 10-second period. Okay. Now, let me play this. So what's going to happen the first 5 seconds? It's going to sit there, then it's going to start moving, goes to a position, and it goes back to where it was. So here, there. Okay. Oh, you know what? Reset. I forgot to put it in the other direction. Double click. I need a minus sign here. That goes in the other direction. You say okay. Now, simulation with laws. Play it. It's going to sit there and then go back. Okay. The only thing is that my velocity, this is over 10 seconds. So let's go ahead and find out what happened, because I didn't want it to go that far back. So let's go ahead and fix this. Double click. Okay. So 5 inches minus that. So this is 7. Yes, that is 7. That is 7. Remember the time shift? 7 seconds. All right. So, okay. Let's put this thing back where it was. Yeah, good. Let me reset it. Good. Now we're going to say go. There we are. Now, how do we know if we have made a mistake or not? So one way of checking is the following. Activate sensor. See that? Activate sensor. Activate sensor. You see that? It says, of course you can go and create a sensor, plot the velocity, plot the position, etc., and then look at the position and compare it to that. You can do that, and you already know how to do that. But what I want to show you here is that, look, I'm not going to create a sensor, but I'm going to check whether the rule that I wrote actually is working or not, exactly what I want or not. So I click on this, see that? It says this is the sensor is the length. You click on that, say yes. Okay, move this thing out of the way, play it, sits there, go back. And if I plot it, or graph it, I should be getting this. This is that. All right? Good. That I'm going to do, and in fact, is the second problem that we did about 2 weeks ago, 3 weeks ago. But there we specified the constant angular velocity for this arm. Here, the angular velocity is not constant. You can see that it is constant in the first 3 seconds, and then it sits in that location. Basically, angular velocity becomes 0, and then again it has a constant angular velocity that we have. So the moral of the story is that I cannot describe this thing as a single formula. I have to write a code for it. Okay, and I'm going to do that for you, but the code that you're going to see is going to be very similar to the one that I did a few minutes ago for the block traveling along the track. And remember that it's very fussy, in a sense that don't leave out the units, don't leave out your units. Make sure you write these things either like that or 60 DEG underscore S. It's entirely up to you. Anyway, so we're going to do that. Let's go ahead and do our problem. I'm going to start with dimensions don't matter, but let me go ahead and make a base. So start with a product file new product. All right, and immediately save it. So file, save management, save as. I'll call this thing, I'll make a folder here. So new folder, rotating arm with the rule. Okay, not a formula. All right, so everything is going to go in there. And I'm going to insert the base. So remember, you have to be in assembly design to do that. Right now, I'm in DMU kinematics, so it can be done here to insert a new part, etc. But I'd rather do it in assembly design. So it's a matter of choice, which one you prefer. So insert a new part in there. And I'm going to call this thing the base. Right-click properties, base. And base. You say okay. Now we're going to make it on a convenient plane. On that horizontal plane, I will sketch just a cylinder and pad it, or just a circle and then pad it up. Exit, pad it. That's fine. This is going to be my base. Okay. And then all the way in the top, insert the arm, insert a new part. Call it the arm. Arm and arm. We say okay. Double click on it. Now on that plane, I'm going to sketch something that resembles that arm that you see there. It doesn't have to be, but I'm going to make it look like that. That's fine. Okay, exit. and then pad it. So this is going to be my arm. I'll make this thing 0.3 so that it looks nicer. Good. All the way to the top. There are no assembly constraints here because I'm going to use the magic wand. I might as well put some constraints here. I'm going to anchor the base, and then coincidence between this axis and that axis. Oh. Okay, let me control that here because I don't think I did it right. Let's try it again. Coincidence between this axis and that axis, which happens to be already there, and coincidence between this plane and the bottom plane. Or you can also use the top plane, but there's going to be an offset there, but that's okay. I'll just make it easier for me. So I just use the making surfaces all the way to the top. Click on the floppy. It's going to save everything. And now we're going to go to digital mockup, DMU kinematics, get the magic wand out. Okay, so first of all, let's create a mechanism, new mechanism. Mechanism number 1, auto create the joint. There'll be a single revolute joint, degree of freedom 1. We're going to make that the angle driven. So say okay here. Double click on revolute 1, make it angle driven. The direction is like that, that's fine. So we can check it out. If you do the simulation with command, you can see that you can turn this thing the way you want, reset it. Very good. And now I want to write the rules, okay? So how do you do that? You go to, let me remind you, you go to the knowledge advisor, and basically write the stuff, okay? So let's do that. So we go start, knowledge advisor. Notice that this thing pops up, remember reactive features. Okay, so you click on the if X, etc. So it's rule number 1, okay, by me and the date and everything. Say fine, and then you start typing. So let's go ahead. Remember, we don't want all this junk here, so we just want the stuff about the mechanism. You click on the mechanism, only the thing relevant to the mechanism pops up. All right, so here is the way. If time is less than 3 seconds, uh, the thing is going to have a angular velocity of 180 degrees over 3 seconds. Okay, so that's going to be 60 degrees per second. Okay, so here's what we're going to do. We're going to type if time, here is the time variable, less than 3s, enter, and angle, there's the angle equal to, obviously we start at 0, so I'm not going to write 0 anymore. I'm going to just say equal to 60 DEG underscore second. Or if you want, you can write 60 degrees divided by, 180 degrees divided by 3 seconds, if you prefer. And if you get a syntax error, we're going to put these things in parentheses, and we're going to have to clean it up, basically. Times, time, there's a variable time. Okay, enter. Else, if time is less than 6 seconds, let's go back to our graph here. 7 seconds, 7 seconds. 7 seconds. Oops. 7 seconds. And then we get the angle equal to, remember, it is sitting at 180 degrees here. Okay, so it's going to be 180 degrees DEG minus, plus time. The speed is the same thing still. 60 DEG underscore S, same speed. Okay, If these things confuse you, put them in parentheses or write them a different way. Times, parentheses, time, there is a time. Don't forget the shift, minus 7 seconds, 7s. Okay. And then hopefully we don't have an error message, we don't have a syntax error. Oh, you know what? Actually, I made a mistake here. This is 0, right? This is 180. This is 180, right? You know what? Let me copy this. Let me copy this. I already told you the trick. Control P, Control C, okay? And then clean it up. So that's wrong. 180 degrees, right there. Right there. Enter. Else. And then Control V. There. And that is it. Okay? Hopefully there's no syntax error. Let's check it out like that. No syntax error. Good. So let's make sure that what is the issue here? The relation generates cycle with rule 1. It will be deactivated. Okay, so you see units, there's a problem with units. Let's go clean it up. Definitely there's a problem here. Let's check it out. Let's see now. If mechanism is less than 3 seconds, 60 degrees per second times time. Oops. Okay, so here, yeah, that's good. Else, if mechanism is less than 7, oh, this is not the right one. Brr. This should be that fellow. It should be this. Yep. Same thing here. That should be angle equal to that. Okay. Let's make sure we don't have a mistake. Yeah. Great. We say okay. All right. And let me update this thing. See if let me update Control U. Control U. Well, let's try it from here. Okay, this still okay. It was deactivated, unfortunately. So let me do the following. You know what? I'm going to copy all of this. Actually, this stuff, I'm going to copy it. Control C. Close that. Delete this. Add another rule. Remember how to do that? You go to KnowledgeWare, Knowledge Advisor. Click on that. Rule number 2, and just Control V, right? Control V. Okay. So this is all correct. And then say okay. There we are. And now we're going to go to mechanism. We're going to go to mechanism design. Let's go back here. You can go from here. If you want, you can go to DMU kinematics right there. We are there. And then simulation with laws. All right. And 10 seconds. Okay, so let's see. Yeah. Sits there. Goes like that. Now, how do we know if it's right? You go back there, activate sensor, select this, and then run it. We better get that graph that we inputted. Very good. This better be that. Now remember, the mistake that I made when I was running into that issue, inadvertently, I wrote down time equal to ... I meant to say angle equal to ... Remember, if you want to save these things, you have to go through the usual thing, capture the image. You cannot save this thing. If we ask you to provide information to us, you can go and use a screen capture of this. save it as a image file or put it in a Word document, etc., and submit as part of your work for marking. Okay. Um, yeah. Uh, we could have asked you to generate a velocity or acceleration, blah, blah, blah. It's different. This is just to show you whether the program that you wrote is correct or not. All right. And I'm sorry about this thing. I ran into problem because instead of writing the angle equal to this, I wrote down uh, mechanism one kin time equal to that, and that's why it gave me this. It's a circular, relationship. So time equal to time, blah blah blah. Blah. Okay. So that takes care of this problem. Is going to be a combination of rotating arm on a block that is traveling down a path. And the rules that I want to put in there for the position of the block as a function of time is like that. Okay. And for the position of the arm as a function of time is like this. Just to make my job easier, I have calculated these velocities. See that? For example, 8 over 4 is 2. Of course, this is stationary here. And then also 8 over 2 is, 8, 8 over 4 is also 2. Here it's going to be 720 degrees over 4 seconds. So it's 180 degrees per second, etc. So that's to make my job easier so that I don't have to go back and forth between the screen and the formulas. Now, here is the code. So basically, I have to put this thing in my rule. Now, I'm going to do this problem putting both of these commands in the same braces, okay? Because there's two things to be satisfied, two relationship, two equations, two formulas. You have to put these in braces so that they're simultaneously executed based on this condition, etc. And then I'm going to come back and make a rule for the block, make another rule for the arm, and put them in separate rule, separate rules instead of putting them all in the same one. So I'm not going to go back and forth between this screen and what we're going to do is just that, yeah. So I'll just type whatever I have on my piece of paper. Okay. All right. Let's go ahead here. We're going to make our, the only thing is that for convenience, I said 11-inch long, 1 by 1. Okay, very good. Let's go ahead and make it. So start with a, a product file. And I'm not going to bother saving, which is a bad idea. Insert a new part in there. So this is going to be the base or the track, properties, track. And track. Okay, let's make it. On that vertical plane, I will sketch. Something like that. Okay, exit. And pad it by 11 inches. This is my track. All the way to the top. Insert, new part. This is going to be my block. Properties, block. And block. Okay. Let's go make it. On that plane, I will sketch. Where is that sketch? Sketch. View. Rectangle like so. Okay. So this control that. Make it coincident. Exit. Pad it. By 1 inch. Really doesn't matter. All the way to the top. Insert a new part in there. And I'm going to call it the arm. How about calling it prop, as in propeller? Properties, I'll call it R. Arm and R. Okay, let's go make it. On that plane, I will sketch something that looks like the arm. If you click on that, it'll turn it around so you can see this fellow. All right, so here's my propeller. We're going to clean it up in a minute. Exit. Pad it in the other direction by maybe 0.2. Oops, 0.2. Okay, there's the propeller all the way to the top. Let's apply our constraints. Now, as I said, I want to do this thing in assembly design. I can do it. I can generate these joints directly right here, but I'm not going to do that. You can practice it on your own if you want. Assembly design. Let's anchor the base or the track. Coincidence between this edge and that edge, and coincidence between this plane and that plane. That will give you a prismatic joint later on. And now coincidence between the axis of this and that line, okay, and coincidence between, for example, the bottom plane here and the top plate there. That's going to make a revolute joint. Okay, good. So we have constraints here. We go all the way to the top. Let's go to the digital mockup, DMU kinematics. Get the magic wand out. New mechanism. Auto create. There's going to be two joints there, a prismatic and a revolute that you already know right there. And we're going to make both of them, give them commands. So the revolute one, we're going to make it angle driven. Okay. And this prismatic one, we're going to make it length driven. And I want it to go in the other direction. I flipped on the arrow. Good. Now, needless to say that we can individually simulate, individually give these, move these things. You can see that. But I'm going to reset everything. We're going to put some physics into it. Right now, there's no physics. So you go to the start, knowledgeware, knowledge advisor. Here is your if X, Y. You click on it. It's a rule, okay? So we all call it rule 13. Lucky number. Okay. And then we're going to type in this stuff. So I'm not going to go back and forth between them. So I'm just going to go and type it. So here, if, let me see, if kin time, let me click on the mechanism so that we get only the stuff related to our mechanism. Remember, there's two commands here and a time. If time is less than, I believe, 3 seconds, yeah. Actually, 4 seconds. Less than 4 seconds. All right, so because we have two things to be specified, we need braces here. Okay. First, let's do for example, the command for the length. There is the command for the length. Equal to, all right, equal to, remember I said the 4-inch, look at it, 2 inch per second, right? 2 inch per second. So I'm going to write it like that, parentheses, 2. I don't even need parentheses, so let me not write it. 2in. If we get a syntax error, we're going to clean it up. Inch per second times time. Right there. Okay. And then enter. Then we get the angle. Angle equal to, I worked it out, 180 degrees per second, 180 DEG underscore S times time. Close the braces. Close the braces. Enter. Else if time is less than, now if you look at that, it's 6 seconds, it was 6 seconds, right? 6s, enter, braces. Let's again start with the length. It's equal to, look at it, it's equal to, this is going to be 8 inches, right? 8 inches, 8 inches, right? So it's going to be sitting at 8 inches plus, yeah, it's going to stay at 8 inches. That's fine. And then enter. And the angle is going to be at 720. So there's the angle command equal to 720. Don't be afraid of making mistakes because you can go and fix it. If there's a syntax error, close the braces, enter. Else, this is the last stage. Else, enter, braces. Now here time is going to be, or length is going to be equal to 8 inches, but then minus, because the velocity is backwards, minus 2 in underscore s times parentheses, time, is the time, minus, that shift is minus 6 seconds. 6s, okay, enter, and now angle equal to 720 degrees minus, minus, what was that speed? It was 90 degrees per second, parentheses, 90, or I don't need parentheses, 90 DEG underscore S times, parentheses, time minus 6s. Hopefully there's no syntax error. Close the braces. Don't forget the braces. Don't forget the braces. And let's check for syntax error here. I don't see any. So basically what I did is, I typed this stuff for you and I said, don't forget the braces. Right? And we say, okay. Okay, one more time. There is a problem here. We made a mistake. Let's go check it out. Let's go to our rules, see where we made a mistake. Let's see now. 6 seconds, 6 seconds. This is degrees. 2 inches per second. This is all okay. Oh, this is degrees. This is degree, DEG, not 720s. DEG. Yeah. Okay. Angle equals 720. Yep. And now, no issues. So we go simulation with laws. Let's activate the sensor. Both of them. One is for the velocity, one is for the block, the other one for the arm. And let's play it over 10 seconds and then graph it. We better get those two graphs. Yeah. Yes. Because remember those velocities were slower and reversed. So when I say graphics, I better get those two graphs right there. And these two graphs are these two put together. So what I'm going to do is I'm going to repeat this, except that I will use two different rules. One for the prop or the arm, the other one for the block. Otherwise, this is particularly important if those breakpoints are not the same. In other words, things change at different times for the arm and the block. Remember, saving whatever we want is your responsibility. If he asks you to provide us with this graph, you have to screen capture it, save it as a Word document, JPEG, I don't know, something like that, and submit it with your work. If he asks you to generate a sensor, velocity, acceleration, etc., any graph that you generate and you're happy with, you have to capture it and give it to us in the form of a JPEG, or you put the stuff, copy and paste them in a Word document, and then submit your Word document for mark. So the last thing, I'm going to repeat this problem, except that I write two separate rules, rule 1 and rule 2. I'm going to repeat this exact same problem, except that I will be using two rules instead of a single rule where both commands were specified. And notice that if I do that, these are the two rules that I'm talking about. All the breakpoints seem to be the same, and that's why I'm going to cheat, and I'll make a copy of the text here, and then paste it, and then clean it up. Okay, so let me go back there. Let me go back to yeah. So clean it up for the things that are not needed. Basically, you get two clean rules, one for block, one for the arm. And if you plot the stuff, we should be getting the same graph. Notice that there will be two rules specified there, arm rule and block rules. So let me go here. First of all, I'm going to delete this. Before I delete it, let me do a copy the text here, because I'm going to need a lot of this stuff is going to be the same. I'm going to do control, what is that? Control C, okay. I'll get rid of that. Let me actually delete this. Let me start with another one. Now remember, in order to create rules, you can go to knowledge advisor, click on this F of FXY. I'll call this thing rule for arm, or rule for the arm. Okay. And then do a control V here. Control V, so that everything that I copied is going to be there. Now this is for the arm, so I'm going to take anything that I need, that I have for the length out. You can either just literally delete these or make them a comment. Okay, that's entirely up to you. So in the text here, I have actually deleted them, but you know what? I'm going to make it a comment. How do I make a comment? I just put a I think it's slash star star, or I'm not sure, but we'll find out. Let me do it. Yeah. So let's see if we can find a comment here. Keywords, the comment. I can't find it. I don't know. We'll find it. We leave it like this. And then I'm going to take this braces. Oops, not there. I'm going to take the brace here out. Okay. So this is if slash star star is in fact comment. Well, that's great. Then, actually, you know what? One star, not star star. Okay, because you can see on the top it says control star, and then you have to. I think you have to enclose it in a star control, probably. Star slash, not control, star slash. Okay. All right, and do here. Once again, I put a star slash star, and then a star slash. I think anything between that star and slash will be comment. And I need to take this braces out, or put a brace on the other side. Doesn't matter. And same thing down here. Star slash. It's not there. Right there. Slash star. And over here. Star slash. And take this brace out. All right, so this is for the arm. Okay, notice that the only commands that are applicable here are the angle. We say okay. We can always check for the syntax. No syntax error. You say, okay, so this is the arm rule, and do another one, and I'm going to call this thing block rule, or rule block, rule underscore block. Say, okay. And once again, Control V is going to write everything. Control V, going to write everything. And I'm going to take everything that is associated with the angle. So, for example, that goes and slash star slash. Now, because we have braces here, we don't have it on the other side. Either you put braces on this side or take that away. That's entirely up to you. So that's what you're doing. I'm going to take this away and I'm going to comment this out. Okay. Once again here, take that out and put a star slash star and star slash. I could have deleted these if it's confusing you. Hopefully there's no syntax error. Yep, no problem, no syntax. So there's two of them. Okay, very good. Now we're going to go back to mechanisms, either double clicking on this or yeah. And then we go with simulation with laws. 10-second interval, activate sensor. These are the two that are activated, because if I get a graph that is like the one that I have, then my program is correct. And I think it will be okay. So let's go ahead. Now this is going to go back. Very good. And if you say graphics, I should be getting those two same graphs back. Now, just to remind you, let me rewind this, close that. Remind you that in here, I did not use comment. I just deleted the stuff that I didn't want. For example, completely, this is completely gone. This is for the arm. Okay, this is completely gone. If you feel better doing it like that, by all means. That's for the arm. Good. Say okay. And now we go to the block. Anything that is commented here, we can take it out. There we are. And that'll be the same thing. I can run it again, but there's no point in doing it. Now, I mentioned to you why this may be better, because if these breakpoints are not the same, for example, this is 4 and this is 3 and this is 6 and this is 7, etc., then you're going to need a lot of else if. But if you're breaking it up like that, it's going to be fewer else ifs that we need. That's pretty much it. Good luck.